solve it for the V belt, where terminologies of the sine theta and cosine theta will come into the picture. So the static stress due to tension in the tight side will be taken as sigma 1, so T1 upon Bt, where that cross sectional area B into T, B width of the belt, T thickness of the belt, and centrifugal tension sigma C Tc upon Bt. You can also calculate the bending stress due to curvature effect of the belt around the smaller pulley. So that is Et upon D. You can calculate the bending stress, Et upon D, where E is the modulus of elasticity and D is the diameter of the pulley. So these three stresses are important from the subject point of view. For the safe design, the maximum stress in the belt should be less than or equal to the allowable strength of the belt material. So allowable strength, that is sigma D. The maximum stress that will be equal to the sigma 1 plus sigma C plus sigma B. It must be less than or equal to sigma D. It is given here. It must be less than or equal to the sigma D. Similarly, for the condition of for the maximum power transmission, this is the above equation will be helpful in the design or checking the strength. Condition for the maximum power transmission. So you can write this equation P T1 minus T2 into V, or you can further modify it as P is equal to T1 VC, C is equal to 1 minus 1 upon mu theta. So we put these values here, it will come like P is equal to TB minus mv cube C. So for the maximum power, differentiate it with reference to the velocity, dp upon dv maxima. You go take the maxima of this. So for differentiating it with reference to v, equating it 0, you simplify it, you will get a condition that T minus Tc is equal to 0 or T is equal to 3 Tc. T is equal to 3 Tc, which indicates that when the tension is 3 times of the centrifugal tension, in that case, that is the case of the maximum power transmission. we will be using this equation. You can also plot this curve. So that's all about theory part of the belts. Now let us take a problem. Please note the problem. 2 V belt section. 2 V belt section transmitting the power on the grooved pulley. Angle of the grooved pulley is 35 degree. The belt angle is 40 degree. The driver pulley of 300 millimeter diameter runs at 1500 rpm. And driven pulley at 600 rpm diameter. 600 millimeter diameter. Mu, the coefficient of friction between the belt and the pulley, is 0.3. The power transmitted is 150 kilowatt. You are supposed to determine the centrifugal tension, maximum tension, length of the belt for the open drive, designation for the belt, the speed at which the maximum power can be transmitted. So these are the some points. Can write the data given. As is given here, V belt section B. So the design data handbook, you will take some values. One of the value, that center distance will be chosen as the 900 millimeter, and mass per meter, M is taken as 0.193 kg per meter. Number of the belts, N as 2, small n as 2. This data is already given. Driver of the pulley is given, driver pulley and driven pulley, and driven pulley speed is also given. So now you calculate the parameters as per the standard formulation of the belt drive. Pitch line velocity 2 pi n by 60 into r. R omega से निकालते हैं ना, you will be able to calculate the pitch line velocity. Centrifugal tension, you will be able to calculate. Pitch line velocity is known to you, you will be able to calculate the centrifugal tension. So TC is known to you. You can, P is equal to T1 minus T2 into V, where, of course, it will be into NV. So you put it here, T1 minus T2 power upon NV. Put these values here. So you will be getting the T1 minus T2 as some value here. Center distance is taken as 0.9 meter. So wrap angle you can calculate 180 minus 2 sine minus 1 d by d upon 2c. Yesterday we discussed this formula from these formulations. So wrap angle you will be able to get, and wrap angle, that is of course for the smaller pulley आपने पहले निकाला था स्मॉलर पुली के लिए, फिर लार्जर पुली के लिए you subtract it from the 2 pi, you will get that value also theta A and theta B. ग्रूव एंगल दिया हुआ था, हमने अल्फा कहा था, यहाँ बीटा में लिखा हुआ है 35, तो बीटा ये 2 बीटा 35, so बीटा is equal to 17.5 degree. So now you can further, for the V belt, solve this in advance, because V belt के केस में ये वैल्यू ये टर्म आती है ना, तो म्यू cos थीटा ए कोसेक बीटा, इसको सॉल्व कर लीजिए यहाँ पे, and then ratio of tensions T1 minus TC, A1 T2 minus TC mu theta A cos cosec beta. So when you will solve it, you already have T1 minus T2. So from these two equations you will be able to solve the T1 as well as the T2. You simply simplify it and put the values here. So you will be able to get the T1 T2's values. So there is a tension in the maximum tension T1. Length of the belt, we discussed this equation. For the open belt case, this equation we discussed yesterday. You have all these parameters here, you put these values here, you will be able to get the length of the belt for the open drive. So you will solve it. Again, with the help of the section B, that grade you can select the belt. Standard pitch length 30 to 51 millimeter is available. इससे corresponding check कर लेंगे, तो required pitch length is 12 millimeter short or undertake. तो 5 grade less standard belt यहाँ पे टेबल यूज करनी पड़ेगी, वो टेबल आपके पास अभी शायद होगी नहीं, तो ये डाटा डिजाइन डेटा बुक में या टेबल में दिया रहता है. हम आसफ मोहम्मद साहब से कहेंगे कि वो टेबल आप लोगों को प्रोवाइड कर दें, तो उससे ग्रेड जो है चेक कर लेंगे. मैक्सिमम पावर ट्रांसमिशन, ये तो ऑलरेडी हम कर ही चुके हैं. वी इज इक्वल टू टी अपॉन 3m से सॉल्व कर लेंगे. मैं वेलोसिटी इसके अंदर आ जाएगी, सॉल्व कर लेंगे. ये कंडीशन फॉर द मैक्सिमम पावर ट्रांसमिशन, यही 4 पार्ट पूछे गए थे आपसे. सेंट्रीफ्यूगल टेंशन, मैक्सिमम टेंशन, लेंथ ऑफ द बेल्ट पूछी गई थी, डिजिग्नेटेड बेल्ट ग्रेड पूछा गया था, स्पीड एट विच द मैक्सिमम पावर ट्रांसमिशन. So likewise, these type of the problems you may be asked to solve in the belt drive. एक प्रॉब्लम और नोट कर लें. ये नोट कीजिए ये प्रॉब्लम आप लोग. N number of the V belt, section C are transmitting 12 kilowatt power from V groove pulley of 300 millimeter pitch diameter to a flat pulley of 900 millimeter diameter. The driving pulley is rotating at 1500 rpm. The center distance between the pulley is 0.9 meter. The density of the belt is 1100 kg per meter cube. The area of the cross section of the belt C is 230 millimeter square. The maximum stress in the belt should not exceed 2.1 megapascal. The groove angle is for the smaller angle is 40 degree. Coefficient of friction between the belt and the pulley is 0.22. So determine the number of the V belts required. तो ये प्रॉब्लम कर लेंगे हम लोग.
सर ट्राई कर लेंगे.
चलिए इसको ट्राई कीजिए. अगर नहीं होगी तो नेक्स्ट टाइम पे डिस्कस करेंगे फिर क्लास में. अगर नहीं होती है तो नेक्स्ट टाइम पे क्लास में डिस्कस करेंगे. और बेल्ट्स में भी कुछ एक दो प्रॉब्लम और कराएंगे. अभी बेल्ट्स में और कुछ चीजें डिस्कस करेंगे आपसे हम लोग फर्दर. ठीक है ललित, अटेंडेंस दे लो यार. ललित
ठीक है सर.
अटेंडेंस.
हाँ जी सर. ठीक सर. चैट बॉक्स में डाल दें सारे अटेंडेंस अपने.
सर चैट बॉक्स में टाइप नहीं हो रहा. अटेंडेंस नहीं आ रहा है. ललित जी टाइप नहीं हो रहा चैट बॉक्स में.
हो रहा है भाई.
टाइप हो रहा है तुम्हारा, दिख रहा है.
हो तो गया आपका, दिख रहा है.
फोन हैंग हो गया भाई.
हो गई सर अटेंडेंस, लीव कर सकते.